All right. Hi, everyone. So my name's Todd, and I'm a software engineer lead at Curely. And I'm here to talk about best practices in building large Angular applications. So the first thing to cover is what do I mean by large? This is really subjective, right? What I mean by this is really three criteria in my mind. The first is that it's actively developed, probably over the course of a year or more. This gives an application time to accrue the kind of features that kind of fall by the wayside, maybe forget about them, not frequently used, which cause problems and regressions. Also, it's developed by many developers, and the scope of the application is increasing over time. So either the number of features that are being added are increasing, or you have the same number of features, but you're adding more bells and whistles. So I'm just curious, like with a show of hands, who here has developed large Angular applications? Great. Well, hopefully, some of this that I'm going to talk about resonates with you. And for the folks who didn't raise your hands, in the future as your apps grow, hopefully this will become useful. So I want to give a little bit of background of Curelate and how we learn some of these best practices. We started back in 2014 with Angular. Prior to that, we didn't use any front-end frameworks. And today we have 30 engineers across 3 offices. And most of the engineers are generalists. So we have some computer vision and DevOps specialists, but most of the developers are actively committing to Angular applications, including our largest application. And we also have several different feature teams, meaning that particular parts of the application are owned by these different feature teams. No one team owns the application. So I think this is increasingly common in dev shops today, in software development companies. You're doing development across offices, probably across different time zones. There's more and more remote work happening. You're doing development across different teams, and you're building for web and mobile. So different devices, whether that's all the same application or a specific desktop or hybrid mobile app using something like Ionic. And we're in the same boat. This is our stack. And so the main takeaway here is we're using Angular 1.5. So this talk is based on Angular 1. But I think a lot of what I'm going to talk about applies to Angular 2 or other stacks, other tools that you might use on the front end. So the talk is entitled Best Practices of Large Apps. But I think a lot of best practices are associated with development practices and development processes. And one way to think about this is, what's a development process that scales similar to how do you scale a system? So when we talk about scaling a system, one common way to think about it, or one common trope is, you have a system today. It's probably not going to scale when it gets an order of magnitude more load on the system. So for example, if you have a web server, a web service takes 10 requests per second. When you get to 100 requests per second, you're probably going to see problems. And if it's not 100 requests per second, probably when you get to 1,000 requests a second, you're going to see problems. So I think the same principle applies to development processes. What works when you build a 5-page Angular app probably doesn't work when you build a 50-page app. Similarly, when you have a 5-person development team, those processes might not work with a 50-person development team. It almost, in fact, will not work. What works for a 500-line of code app that you wrote over the weekends may not work once it's a year later and you have 5 developers developing a much larger application. So a way to restate this problem is, what are the best practices that scale? It doesn't mean that the way you develop Angular apps, when you're a team of 1 or team of 2 are bad. It just means that some of those processes won't work when your team gets larger, when your app gets more popular and has more features. So a good place to start here, I think, is directory structure. So back in the day in 2014, when we started working on Angular code, this was the directory structure that you saw in a lot of different tutorials. Thankfully today, you don't see this that often, but if you're Googling for older tutorials, you'll still see it. And so the structure of the directories here is based on what the different elements of the Angular application are. So controllers, directives, filters, services, partials. It works great for a to-do app or a toy app. It doesn't work great in practice because the problem is that the files that you're changing most often are going to be in completely different folders. It gets really annoying, and we experience that. So very quickly in our usage of Angular, we switched to this kind of pattern, which separates the files by the files that have the most affinity, the files that you're likely to change with each other. So in other words, this foo directive or foo component, all the elements of that foo component are in the same directory. Similarly, you could have a common directory that has all the common services or filters that you use. And this scales. So if you have, add more features, you add more pages to your website, you can add another layer of hierarchy. You still have that common, but then you can add the subdirectories underneath it. You can add additional directories for the different features that you release. This is really nice, and it scales really well. You can also add your specs here. So you in the previous slide, I didn't have specs, but I had things for the view, the logic behind it, the CSS or styling, or if you use less or some other preprocessor, that could go there too. And optionally a service that has some helper functions or common functionality. But you can have the specs here just as easily as well. Next, I want to talk about components. So again, back in the day in 2014, when we started using Angular, there was basically two ways that the tutorials and the different information out there told you of how to build an Angular application. The first is with controllers. It's easier to get a handle on. It's quicker to implement, but it doesn't scale. The other way is, at the time, was custom directives. Custom directives have more boilerplate. They're harder to kind of figure out, but they do actually scale. And I have a few reasons why I think they do. And today, there's components, which is similar to directives, but has less boilerplate. It's easier to use. And so directives and components are what I'm talking about when I talk about components here. So first, you may have seen this. This is a slide from, or at least a screenshot from a slide back in 2014. The Angular 2 dev team presented this when they were giving a preview of Angular 2. And they're basically saying controllers are dead, along with a bunch of other things in Angular 2. So the first reason why you shouldn't use controllers is because in Angular 2 you can't. You can still use them in Angular 1 today, but to have a better path to upgrading, you should really consider using components. The second is more of a user experience reason, as well as a development reason. This is a slide showing 3 different treatments for a dropdown. And dropdowns are really simple. They've been around forever. But you can see these are vastly different treatments of a dropdown. The left-hand side one, the initial state looks more like a button. The middle has some additional functionality you wouldn't see in a native dropdown, like icons. On the right, it gets even more complicated. Hopefully, you wouldn't see all 3 of these in one single application, but it's illustrating that even simple functionality can diverge. And what I'm trying to illustrate here is that if you have multiple teams working on a project, they're ultimately going to want to add functionality to these common components that didn't exist before. It's a natural thing to do. It's a good thing to do. You want to continue to advance, the usability of your system, add improvements to it. But the bad part is if you didn't add it to a common component, then your system doesn't feel cohesive. You'll have older pages that use dropdowns in a different way. To the user, it doesn't feel like one system. It starts feeling like multiple different teams built it, and you don't want that. So with the components, it forces you to add that functionality into the component itself. If you're going to add icon support to the different options, you're forced to have to deal with the fact that everybody else is using that component, and it has to be compatible with it. Another benefit for components is that you can bake functionality into it. This is kind of a non-obvious example, but it's a really powerful one that we use, and it's adding instrumentation to components. And what I mean by instrumentation is if you're using Google Analytics or some other web tracking tool, you want to see how users are using your application, and you don't want to have to build that every time you build a new page. So if you're using instrumentation, you want to bake that into your components. So, you know, the 10th page that uses a dropdown, the 20th page that uses a dropdown, all you're adding is something like a tracking category to say, I'm on the settings page, I'm on the home page. This is simple to do, but it's really powerful. Next, I want to talk about linting. And my advice here is that it's really easy to set up with Gulp and ESLint or whatever toolchain or linter you want to use. And it behooves you to do it early. The reason is that you could get into a place where if you care about linting and care about the coding standards and them being the same, you could get to a point where if you do it 2 years down the line, you'll have a whole bunch of errors that you're going to need to fix. And it's going to be low pri. You're not going to want to go and fix 500 errors. You're going to want to build that next feature. So it's really hard to do that. So doing it early is great. It's easy to set up. And another thing with linting is sometimes it's hard to converge on rules. Everyone has their different flavor. So I would advise using an existing rule set and just modify it to your taste. I think Airbnb's is a really good example to base this off of. It's what we based ours off of. And then my last point is, if you're not doing continuous integration, you're not going to get much value out of linting as your team grows. If you're one person or two people, it's easier to say, hey, like I ran your thing and it fails I see linting errors, can you fix it? But if you have 5 developers or 10 developers and it's not failing to build, again, it's low pride. People are not going to want to go back and fix it. The next thing I want to talk about is a living style guide. So for the designers in the room, they're very familiar with style guides or developers that work closely with design. It's a way to have cohesive style across your application. And a living style guide is basically, instead of it being a Photoshop file or a PDF, it's actually a web page. So I have a few screenshots of our style guide. This is showing the different colors that we support. This is from the palette that designers use when they're mocking up new pages. We have buttons, and this is taking a lot of stuff from Bootstrap, which we use. So it looks like the Bootstrap components page. The buttons are the same dimensions, it's just the colors are different. But the really powerful part of this is adding components to this. So it's not just the look and feel, it's the functionality behind it. The benefit to this, there's actually several benefits to this, but one benefit is that it helps to enforce components to be designed for reuse. And what I mean by that is that if you have to put it onto a single page and everything has to work and work correctly with each other and fit and the margins aren't weird, it's a forcing function to make sure that it can go on other pages. It's not perfect, but it's a way to kind of get better than not doing it. And so the other part is that a lot of this is requiring adhering to a process. It's very easy, I think a lot of developers realize it's very easy to say, okay, we're under a time crunch. We need to ship this feature. We'll add this to the design guide later. Or we need to add a V2 version of this component. We'll combine them later. It's hard. It's hard to adhere to this, but if you can adhere to it, it's really powerful. It leads to a cohesive user experience. Next is performance, and this applies to apps large and small. But the reason I include it in here is for 2 reasons. First is that it's easy to fall into patterns that lead to non-performant Angular code. You have to be vigilant about that. And as you add more code, it just stands to reason that the more code you add, the more potentially non-performant code you have in the code base. So one way to think about performance is that you want to identify the code that has the most likelihood to be non-performance. Obviously, you want to measure that. But one way to identify the likely culprits is to think about how code that executes the most frequently is the most critical to performance. So I mean 2 things by this. First is that if you have code that users run all the time, so it's on a very popular page or very popular sections of the page, it's more likely that that performance problem is going to hurt them. It's going to feel slow. They're going to be upset. They're not going to want to use your app. So that's more critical in the sense that that should be your priority. It's affecting the most users. The other side of the coin is that code that executes most frequently, even if it has a small performance problem compared to something else, affects things more. So if you're executing something 1,000 times, even if it has a small performance problem, that magnifies 1,000 times. And so here are some concrete examples of where this comes into play, and this has come into play for us. First is third-party libraries. And I think third-party libraries, they vary in terms of quality, so it's hard to know what ones are performant, what ones aren't. The star rating on GitHub is not always the best indicator. So that's always something to look at. Second is your custom functionality. So filters and services, things that are used across your different components are likely culprits. Also common components, so things like a dropdown. If there's something that's not performant there, it's going to be magnified just because it's everywhere. And then code with an ng repeat. So if the code within a single page or a single template is executed a lot, that performance issue is magnified. Another tip here, avoid unnecessary two-way binding. So I think it was Angular 1.3 to add a native support for this. Prior to that, you could use third-party libraries for it, but this is really key to keeping the watcher count down and making sure that your apps are speedy. I would actually think of one-time binding as your default and using two-way binding only when necessary. Another one here, so this is something that we haven't done yet, but I wanted to bring it up because it's a good example that we found where letting measurements guide you is really the approach to performance. So we don't split up our JS into multiple files. We have one file for our libraries, one file for our custom code. It's been like that for a while. And we haven't considered splitting up the JS yet. But one thing we did consider was pre-caching all our templates. So in Angular, there's a template cache, and you can pre-cache templates using your tool chain. So like there's a Gulp plugin for it. So we said, oh, this is a clear win. Like you don't have all these AJAX requests every page load, or at least the initial page load. If you're setting the right cache headers, it wouldn't happen on subsequent page loads. But the problem is that with pre-cache templates, if you don't split up your JS files, what you're doing is you're downloading and executing JavaScript that sets the templates in the template cache every time that JavaScript runs, so every page load. And the problem for us is that execution time actually was worse than the savings that we got by not making those AJAX calls in the initial page load. Performance problems can be counterintuitive. So measurement should always be guiding you. Another one that we found to be kind of tricky is sharing our code across projects. So we have a desktop application that's Angular. We also have a hybrid mobile application that's built on Ionic. And Ionic is a library that uses Angular under the covers to be an app that you can install on your iPhone, but actually executes Angular for the view and logic. And so we share code between the two projects. And what we found is that filters and services, things that have common functionality that don't touch a view, are easy wins here. But you have to really think carefully about sharing templates and presentation or component logic. When the presentation logic differs, it leads to really tricky situations to get that code right. If your logic diverges between the mobile app and the desktop app, it leads to problems. And so you just really have to think through, if your code's going to diverge, your logic's going to diverge, you should really think hard about sharing templates across web and mobile if you're doing hybrid apps. So in summary, things that we've learned are use a good directory structure, use a linter early, and a linter error should be a build failure. Use components and not controllers. There's a variety of reasons to do this, including upgrading to Angular 2 will be a lot easier. A living style guide has a lot of benefits, but you have to adhere to a process and you have to get buy-in from design to make it work. Performance will be an ongoing struggle. You'll have to be vigilant about it for every new feature. And you should let measurements guide you when you tackle performance problems. And that's it. Thanks.